first thing we need to discuss, and that is like encryptions. Okay, that how the encryption is being done in Kubernetes cluster. After that, we need to understand a little bit of network traffic, some network policies and all. Then we need to discuss about how to secure kubelet. Then we need to discuss some of the other tools also, like a kubebench and stuff like that. We'll also discuss
Sure.
and do the upgrade of Kubernetes cluster, and then we'll get into the service account, role RBAC, and all stuff like that. Some external tools we do have, like App Armor, for the system hardening, which will use it.
Right.
We'll get into the container to run C and all stuff like that also. Kernel level hardening, and then
Okay.
we'll get into the one more tool which is called Zvisor for the system hardening, and few more topics also with authentication,
Okay.
authorizations, and all stuff like that. So this is the topic which we'll cover today, and tomorrow also accordingly I'll share with you. Okay, so let's get started. So first thing, we are going to understand security practices which we follow during the cluster setup. So in Kubernetes, we encrypt all API traffic. So all the API traffic which we are using is encrypted. So for that to understand, you need to have a little bit of idea about the TLS certificates.
Yeah.
Certificates used in the Kubernetes. We'll create a certificates, configure components to encrypt the traffic, and using the certificate API and stuff like that. So now the question is, what is a TLS certificate? So a TLS certificate, what is TLS certificate and why do we use it? So if you look at this here, there is one server, right side, and there is one client. Now, any traffic which we process through HTTP, okay, it's not a secured mode. So let's say you are sending the user ID and password. Now, this is a unencrypted
Right.
packet you are sending and to the server. Now, this may get stolen. This may get stolen, and this packet may read what is username and password, and hacker again can directly use that information against the server to get the desired results what they wanted to get it done. Now the question is, how do we encrypt this? So let's say from the client side, okay, from the client side, again, when you encrypt this, you have a keys and then you encrypt this. So again, that hacker also can get this here, this information. And when you send this key, the encrypted key to the server end, then there's a chances like, this information may get misused. So here, what I'm trying to say here, TLS certificate, we need to enable. So using the HTTPS, you are sending the details like user admin and password, and that is encrypted, and you are sending the data plus key over the network, whereas you have a key. Okay, let me just say here. So let's say this is the key, user key, this is the client, this is the server, and this is the hacker. Now this information which you are sending and encrypted with this key. So if you want the server to decrypt this key, you have to send this key also, correct?
Right.
So this
Right.
information is encrypted, but also you are sending the key here. So now this hacker also can get this both the things here. So you can get the information of and decryption key also. This is it is being sent here, and server will receive that. So this is also not a right way to do the things.
Encrypted.
Yeah. So what we do in TLS certificate, what we do in TLS certificate. Let me complete this. So here, understand that first thing, the data which we send, this is this is the right information. So the data which you send, basically, you have certificates. So see here, this is the key. This is the one certificate, and now you are sending this one key and certificate. So now the hacker may have a certificate, that's easy to get it, but it's been sent to the server, and he will not have a ways to decrypt it, because this the key is lying here. So what you did, this certificate, look at this my screen, this is a certificate.
Yeah. Yeah.
This certificate has been used, this certificate has been used to encrypt this key, this certificate. Okay, so this is the key and this is certificate. Now you are sending the data. So hacker have the certificate, of course they have it, and they'll have this one also, this part also. But the problem what hacker will face, they will not have keys to decrypt this particular key, because the private key is here, and this has not been shared over the network. So if this particular part is not shared over the network, so hacker will have a encrypted data, will have a key also, will have a certificate also, but not a key for decrypt that encrypted key. So that way, in the using the TLS, we using the TLS, we protect this information from the hacker, and that way it's
Okay.
considered to be safe.
Okay. Got it. Yeah.
Understanding? Are you understanding?
Yeah. Yes. Yes. I got it. Yeah.
Yeah. So this is something how the TLS works. So now all this information is secured. Now what happened? What happened? Uh, what happened? This is the image. To avoid these issues, hacker may impersonate, saying that I am your server. Okay.
Okay.
So
Okay.
now this is not your server. This is your server. So when you encrypt the key with the certificate, okay, when you encrypt the key and with the certificate, then decryption key you may be having lying here also. So just to avoid that, what we do the double encryption actually. So we send the packet first. What we do, this is the your key. You send this key to here. This key is you are having here. Okay. After that, using the certificate, they will release the certificate which is here. So now you have a key and certificate. This has to be conjunction. The to to decrypt this all combination, you have a key here. So that means, let's say, if you are next time you're going directly and sending the key here, okay, that you sent it, and then when you second time when you get a certificate, that means you will be authenticating this server. Okay, and then you'll be authenticating this server, but still this part of the server access will not be having, because this key is unique, and this key and this certificate is unique, this key and this certificate is unique. So here, that's also second layer of security is been set. So you, if hacker is saying I am real server, and that's where the certificate authority is coming. So now this part, so someone should not impersonate. For this part, many public certificate authority is being used to avoid these issues. Now this public certificate authority is the you can say like is the only authority which is governed by the government also. They can validate and they can sign the certificate and all stuff like that. So whole internet will trust this server only, not hacker. Means hacker to become and issuing a certificate, they need to be recognized, which government will not do that. So the only few public uh, CA are there, you can say, a certificate authority, which is recognized by the internet and government. Something like Semantic, GoDaddy, AWS, and Google Cloud and stuff like that. Okay, so that's where
Okay.
that
Okay.
public certificate authority is coming. But actually, anyone can become a anyone can become a public. Anyone can become a CA basically. So now what will happen? Your server will sign this certificate with the help of other CA, and chances of having this signing process misuse is very less because of public authority. So this is
Okay.
how the server will, when you send a client from the client, you send the request to the server. Server will validate the certificate from the certificate authority, so no one can personate about these changes. And this CA will say yes, this is the valid certificate, and all this thing can happen. So this is how, at a high level, TLS certificate is being used. So secure the packets which we send over the network. So anyone can generate a CA, anyone. So in this session, we'll do that. But only public CAs will be trusted by the most of the system on the internet. Make sense?
Got it. Yeah. Yeah.
So, yep. So now this entity is a client, this is a CA, and this is your server. Okay. So you can say I trust this server because it's providing the certificate signed by someone I trust, which is you. Okay. So now this I don't trust this server because it's providing certificate signed by someone I don't trust. So this is what happens.
Okay.
Done. So here, one important thing which we have is client also need to generate their own pairs of keys and certificates signed by trusted CA. Okay. So in order to have a TLS certificate security implementation, client also need to generate their own pair of keys and certificates signed by a trusted CA. So that also I'll show you in the demo how it's been done. So now this is something which I discussed about that how we do in the public network, like a website server. For website,
Right.
we have a CA, and like I'm using the GoDaddy CA as a for HTTPS for my website.
Okay.
So that can be easily doable and security is there. But the question is, how do we do with a private network? We can't keep spending so much of money on the certificate, public certificate, but our website is not available publicly. So how can we use this same mechanism? How can we use the same mechanism for the private network where these applications are not exposed to the outside, but still we want to encrypt all the network call within the components of system, right? Are you getting my points? Now question is, what are the component of the system which I'm talking about in Kubernetes? So can you please tell me what are the components which we have in Kubernetes?
So we have the API server.
Mm-hmm.
We have the control nodes. Then we have Kube-proxy is one.
Yeah.
And
So yeah. So look at this here.
yeah.
Yeah, please continue. I'm just recording your
Yeah.
statement.
Sure. Yeah. So we have the API server. We
Mhm.
have the uh, control nodes or the control plane and the worker nodes. We have Kube-proxy. We have kubelet.
Mhm.
Uh,
So API server, what you said secondly?
then we have the control plane, the control nodes.
Oh, no. API server, a machine where you are running, that's called control plane. Correct? Now this server,
Right.
we call it
Right.
control plane.
Yeah.
Here, this is the
Then we
control.
have Kube-proxy. We have kubelet. Uh,
Mhm. So you have a kubelet which is running here. Let's say I'm writing here. Kubelet is running as a executable, okay, as a service.
Yeah.
Yeah, that's a
Correct. Correct.
kubelet. What
And
next?
we have etcd.
etcd is in
etcd as
form
well.
of pod, right?
etcd.
Is in pod.
Yeah, it's in the pod. Yeah,
Yeah.
the
What
database.
next?
Kube-proxy.
So I'll draw one more. So proxy. Okay, that is a proxy. Yeah, go on, please.
Um, Other than this, what else is there?
Remember that.
Uh, uh, in the control plane.
Yeah,
Mm,
it's
mm.
proxy.
So there are two more components. What else is there?
I'll remind you. So it's one is controller manager,
Oh, okay. Yeah,
right? And
yeah, yeah. Yeah.
so
Scheduler, probably.
let's have a discussion sort of training because we are only
Sure, sure, sure.
yeah, and will be little odd. And next one is scheduler, correct now?
Scheduler. Yeah, yeah, yeah. Correct.
Yeah. So this is the component. Now here kubelet we have other utility. What we have here kubelet and then Docker, correct?
Uh, Docker or Cryo or
Container
whatever.
D or cryo, yeah.
Run
So, yeah.
runtime, right? Yeah, yeah.
So here I'll just write container D. Okay, it can be Docker because
Hmm.
from now 1.23 onwards that Docker has been deprecated and
Replicated, right? Yeah. Container runtime, container D.
so
Yeah,
either
yeah.
you can use cryo or container D. Okay, so
Okay.
kubelet is there and Docker and container D is there and proxy is there. Now one more pod is there, network pod. Which network you are using?
Uh, you mean Antria or like this CI
So there's one more pod is there
line
which is
or
called Calico. Calico,
Calico? Yeah.
Flannel, VivNet, all these are networking policies which you can use.
Antria is what we are using, but yeah.
But this one, what is it? In the certifications, you need to work with Calico or Flannel
Calico. Okay.
or PaveNet. Okay.
Okay. Okay.
So
Okay.
this is the pod also. This is also pod. Now there's
Okay.
one more utility which is there in
DNS.
yes, a DNS server. So here I'll draw the pictures. Remember that all this component. So here you have
Sure.
two pod of the core DNS right now.
Code DNS. Yes.
Yeah.
Correct.
So here you have core DNS. Two pod you will have it by default. You can increase. By the way, you
Correct.
can increase any of this. That's not a problem. Now here one more daemon, one utility which we use, which is Kube-ADM. Remember this utility always. Kube-ADM.
Hmm. Okay.
Okay. And one more utility is there, which is called kubectl. So kubectl also will be there. Without that, it will not work as a client. So kubectl.
Okay.
Okay. So more or
That's
less.
the client, right? kubectl is the client component, but you're saying it is there on the control plane as well.
So
Correct.
it,
Yeah, yeah,
it
right.
has to be on a control plane because they will make the connection, right? See here,
Correct,
understand
correct.
the
Yeah.
connection. So here, first of all, look at the arrow. API server need to connect to etcd. This is
Right.
so this is the one network call only, correct?
Yeah.
Now here, this also network call. This
Right.
also network call,
Yeah.
right? And here this also network call,
Hmm.
okay, and here how to draw pictures. So this also network call, okay,
Yeah.
and core DNS, this is also network call. Proxy need to talk to API server network call. Kubelet will talk to the this one. It's not network call, it's a socket call. Okay. So these are the API call we are seeing in the control plane only. Now this is my
Right.
laptop. This is my laptop. This is my laptop. This is me. And here you have a kubectl, right? And kubectl will talk to API server only, correct? So
Correct. Yep.
this also need to be authenticated. I mean, TLS certificate for this also needed. Now you see that here. Now I'll draw the pictures of worker. So worker,
Okay.
you will have this utility for sure. In each worker, you'll have to have this utility
Correct.
here, and then you will have proxy also for sure, and Calico pod also you'll have for sure, correct?
Right.
Right? And then one more
Yep.
utility will be there, kubelet is there. So now the call which is happening in the across the network in the cluster, kubelet will talk to API server, right now, and proxy also need to talk to
Yep.
API server. So this is the worker, okay? This is worker.
Yeah. Yeah.
So now these are the calls which will happen. Now, so all this call has to be encrypted. All the API call has to be encrypted. So here user call has to be encrypted. Scheduler, controller, and all these things, blah blah blah. That call should be encrypted. And from the worker also, kubelet call and proxy call need to be encrypted. Correct now?
Right. Yep.
Yeah. So this is something which we have to do that. So now you'll think, Rajesh, okay, fine, it all has been encrypted. So what am I going to do? So basically, all this certificate except this certificate, okay, in fact, including this one also first time. So when you set up a cluster, that this keys is been set up and generated and set up by automated process. Which key? This client key and here,
Certificate.
client key and certificate generated by automatically. Now, where is the CA in this whole system? So this guy is a CA, remember that. Okay. This machine control plane, one machine which will be acting like a CA. Are you understanding?
Yeah. Yeah. And we can use an external CA as well, right? I mean,
You can,
because
yeah,
this is going to be self-signed by this one,
yeah.
right? So,
You
but
can use
if you,
external
yeah.
CA also, but right now that is out of scope because we don't,
Okay. Sure.
because we have to only align with our topics for time being. Others, that will get
Certainly.
complicated. Yeah.
Certainly. Yeah.
So you can use hell lot of other CA also. CA manager you can also set it up. That's a different topic altogether. Okay.
Okay.
So now, so this is a CA. So now we need to generate manually. So manually we need to generate some certificate and update the certificate. So let me tell you, all this work is done by KubeADM, not by me, not by you. But then you'll ask, okay, what I need to learn in this topic, this session. So you may
Right.
get some assignment. You may get assignment where you can update the certificate, which is you call it a retention certificate retention period. That means every 2 months or every 3 months, you should be able to update some of the certificate. Updating the certificate means key and certificate, and so the network that what we have is secure, because if you have a only one key and only one certificate all the time throughout that experience, then it's not a good security practice. So you have to
Correct.
rotate the
Yep.
certificate, and that is what we are going to discuss now. Understood, right?
Okay. Yeah, I got it, Rajesh.
Yeah. So TLS certificate in private network, so generate CA for internal use. We can generate certificates signed with internal CA for internal use. So in our case, our internal CA will be the master machine, uh, which will be acting like a master machine. And
Okay.
add CA to the trusted root certificate in all internal system. This you have to understand. Okay. So add CA to trusted root certificate uh, in all internal system. That means whatever the worker you are using or workstation you are using, that this CA you have to add in this each machine as part of trusted root certificate. Okay, trusted root certificate.
Okay.
This is important. I'll discuss with you, just understand that. And after that,
Sure.
establish secure internal connection. So these are the things which we need to do in the private network. So now let's understand what are the certificate used in Kubernetes. Before understanding this part, we need to have one clusters up and running. So what we'll do,
Right.
we'll go here and set up a cluster. So go for AWS console. We'll set up a two clusters. I will set up one cluster for myself and you will set up one cluster for yourself. Okay.
Okay.
So for the time being, the we have one master and then one worker. Okay.
Right.
Now this is the master machine. We'll have a two CPU and 4 GB RAM. I'm going to allocate.
Okay.
Or let's say okay, 4 GB is sufficient because we have to destroy many times. So it will not be. So throughout this session, you have to create multiple clusters and destroy the clusters also and rebuild the clusters. Many things you have to do.
Sure.
So this is the my server. Now, so I'm going to create. So now that operating system which I'm using for all of us, are you able to see my screen, right?
Yeah. Yeah. I'm
Yeah.
able to see.
So operating system which we are using is Ubuntu 20.x. Okay.
Okay.
And for this also Ubuntu 20.x.
Okay.
Now let's get the VMs ready. So launch instance and look for Ubuntu 22 is there.
Okay. But I may not have. I mean, do I need an account and all for?
No, I'll give you everything. Don't worry about
Okay. Okay. Okay.
it. Everything I'll set it up. So this is the 20.4. Let's use this
Yeah.
one. Okay.
Yeah.
So two CPU is there and 4 GB RAM medium. That's
Yeah.
now how many machines we require? Four machines. Two for
Two.
you, two for
Okay.
me. Now
Oh,
hard
okay.
disk 30 GB. Adding a tag. This is the Kubernetes cluster. And here one worst practice which I'm doing for time being is like network security for the cloud. I am allowing everything. Okay. This I'm doing just for the time being. So at least from my side, there's no blockade. But we'll discuss about which protocol, which port number need to open and which port number need to be closed. I mean, all the port number should be blocked except the few port number. So this I will discuss. Also, here you have from where it should be allowed to where it should be allowed. So that means who should talk to my server, who should not talk to my server. Okay, so this is the
Yeah. Yeah.
network security group. Okay, so security group also I
Yeah.
just for the discussion purpose. Security group also there are, I mean, firewall is also three places, four places in fact. I'm just giving you lead actually. We'll discuss this one in later. So firewall is at this place. One is like OS level firewall. Okay.
Right.
So before that OS level firewall, because you are using Kubernetes and Pod, so here Kubernetes firewall is also there. So Kubernetes firewall, how is been done? So that is done by network policy. means
Okay.
network policy. What's
Yeah.
network policy? So you can say aka pod network level. Pod network level. Okay.
Got it.
So
Okay.
that
Okay.
that also you can implement. After that OS level you can do that. Then next firewall you can apply cloud network level also. Okay.
So
And then
AWS, whatever.
cloud means AWS. So this one, the one which I am showing you, this one is a cloud network. This is sorry.
Correct.
Th-
Correct.
This is the one. So you have to work with all this firewall and see how it can help you. So right now I'm
You
following
said
the
four. You said four or three.
So this is the pod, this is the OS, this is the cloud,
OS
and
and
there is a
cloud.
service mesh also is there. But right now I'm not discussing this one. Service mesh
Okay.
means Istio, Envoy, and Linkder and all
Mhm.
stuff. So this
Sure.
is out of scope for time being. That's where also you
Sure.
can control who should talk to what.
Okay. Okay. Yeah.
Yeah. So here I'll have a one key, which is training. I'll share with you the key and view instance. So these are the machines I got it.
Mm-hmm.
Yeah. So now let's name it this one. So this is the Kate and Raj master.
Okay.
This is Kate, Raj worker.
Okay.
So this is, I'll give it to you. I'll give it to you more machine if you need it. That's not a problem.
Mm-hmm.
Arpit.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to hundreds of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.